Good evening, viewers. Welcome back to Telepedia Tutorials. Now, we continue with the next video, which is going to be solution 3, electrolysis of molten bauxite. Many ores, many metals have the ores from which they are extracted. Example, aluminum is extracted from bauxite, iron is extracted from hematite, lead is extracted from galena. And these are basically the ores you need to know. There are other ones we are going to look into as we move further. So bauxite is an ore of aluminium and it is chemically represented as aluminium oxide. When aluminium oxide undergoes ionization, it is going to form aluminium cation and oxygen anion. As I said, molten electrolysis, only one cation and one anion is involved since water is absent. The aluminium cation will migrate to the cathode, and we express what is going to happen at the cathode using cathodic half equation. At the cathode, anything migrating there will gain electron. We say that it undergoes reduction. Reduction is gain of electron. So aluminium cation gains the number of electrons equal to its valency to now be discharged as a neutral element. Or say we have now recovered aluminium as a metal. We have converted it from ion to a metal. At the anode, the oxygen migrates to the anode. At the anode, oxidation occurs. Oxygen anion loses 2 electrons to form oxygen gas. Please note that whenever you're writing ionic equations for the anode, it's going to lead to balancing of the equation. So since we are having 2 oxygen in the right and 1 in the left, we need to put 2 here to make 2 oxygen. Please note that this represents the charge. It has no influence on the number of electrons. This represents the charge. This 2 minus represents the valency of oxygen. It doesn't indicate the number of oxygen present. But this subscript here represents the number of oxygen present. So I have 2 oxygen on the right, 1 oxygen on the left. And when we put 2 in front, we now have 2 oxygen in the left, 2 oxygen in the right, making the equation to be balanced. Putting these 2 here simply means each of the oxygen will lose 2 electrons to form oxygen gas. So that simply means that the total number of electrons lost for 2 oxygen anions to be converted to oxygen gas is going to be 4 electrons. I'll bring this minus 4 across this, it becomes plus 4. Now, as I said the last time, some exams can tell you to write the summary of the ionic equation. What is the summary of the ionic equation? They are simply asking you to join the equation of the cathode to the what? Anode. In order to join it, the number of electrons must balance. As you are seeing in this case, this is 4 electrons, this is 3 electrons. They are not balanced. We are going to find a number which we use and multiply this. And when we also use a number to multiply this, the number of electrons will be equal. The number we are going to use is 4 here and 3 here. Now this is the outcome. When you multiply the cathodic half equation by 4, use 4 to multiply everything here. 4 times 1, 4. 4 times 3, 12. 4 times 1, 4. And when you use 3 to multiply everything here, 3 times 2, 6. 3 times 1, 3. 3 times 4, 12. When we do this, what do we notice? We notice that the number of electrons are now what? Balanced. So once they are balanced, we can now combine the equation. How do we combine the equation? We combine the equation by first of all writing everything on the reactant side. What on the reactant side? We have A L3 plus 2A minus. So this are everything on the reactant side. Now move to everything on the product side. So on the product side, I have 4Al plus 3O2 plus 12E minus. So that's how to combine the equation. You write everything on the reactant side and I write everything on the product side. Please note, on the cathodic aspect, we have two things on the reactant side and one thing on the product on the anodic aspect. On the product aspect, we have one thing on the cathodic part and two things on the anodic part. Now, since the electron number are equal, you cancel them. When you cancel them, this is going to have 4 here. That's 4 here. When you cancel them, you now have 4Al3 plus 6O2 minus to give you 4Al plus 3O2. Now, when you check the number of elements on the left and right, you can see they are what? Balanced. So this represents the summary of the ionic equation of the electrolysis of molten bauxite. You can say that aluminium is discharged at the cathode while oxygen gas is discharged at the what? Anode. So with that said, this will be all for now. See you next time.